This video is brought to you by Sporlan, quality, integrity, and tradition. All right, we got a call that kitchen ACs aren't working. This one says 81, this one says 84. But what I'm doing is I'm just turning every AC on for a few minutes so I can hear them all and see them all running when I'm up there. But I'll definitely focus on the kitchen ACs. So it looks like AC7 and AC6 are the ACs in question that we need to focus on. Right when I come up onto the roof, this is what I see. This is the kitchen AC, one of them. Condenser's dirty. So I bet you we've got high pressure lockout. And let's go over and look at this one. This is the other kitchen AC right here. And I bet you this guy's all dirty too. Let's have a look. Ah, this one's not as bad. These ones have the older Prodigy board, so it looks like it's running. Don't see any active error codes. Drawn in outside air. This right here is an evaporative cooler, and I don't think it works. It's all plugged up on the inside. Metal mesh filters on this guy, jacked up. And you can't see this right now because this is weird, but it says active alarm 22, compressor 1, low pressure, S87. So compressor 1's off on low pressure, and it's going to have a dirty condenser. That's lovely. All right, first thing I'm going to do is go ahead and clean the condenser, get it cleaned up. Yeah, it's dirty all the way through. So we're going to get this guy rinsed off, turn off power. It's a nice warm one today, 103 outside. So I'm gonna pull the panel, get the condenser cleaned off, and then once we get it cleaned, then we'll finish evaluating the unit. One really good thing is they have very good water pressure here. So everything is just rinsing right down. We may or may not even need coil cleaner, it's so good. And it looks like it's just kind of surface stuff. So we'll see how it works. Get this spider web out of here, and like I said, I'll pull the inside panel and we'll rinse the inside too. When I first do these things, I'm always looking to just get the surface stuff off first, and then we'll get deep into the coil. So you notice how my water's kind of pointing down to get the surface stuff off, so that way we're not embedding it further into the coil. Dang, I forgot how good this water pressure is. Got to be careful though, sometimes this one's so high that it'll bend the fins, so I got to watch out for that. All right, I did a quick rinse, inside and outside, water's flowing through. Now, I'm not going to spend too much more time cleaning the condenser. Like, you know, I probably want to use coil cleaner too, but we got to figure out if this thing actually has a refrigerant leak. We don't want to go too far in the wrong direction, you know, spending hours cleaning to find out it's got another major problem or something. So I've got it clean enough to troubleshoot, rinse the unit off. Look at this guy, big old fat black widow right there. Look at that. Dinner. Looks like she already had her dinner. Look at her husband right there. He's all dead and wound up from her eating his head off. Look at that. She's a big one. She's eating some food right now too. Dang, that's a big one. All right, my unit is back together, back on and running. The filters are plugged on this thing. They were last changed by us in January. Customer's not doing maintenance right now. So those things, you can barely see through them. Those are done, we gotta get those replaced. But the bigger issue is what I feared. First stage compressor has got no gas in it. We're at 1.6 PSI, 1.1 PSI across the compressor. So only second stage is running on this guy. So we got to find a leak, see what's going on. I'm gonna go get some nitrogen, and we're gonna dump some into this guy and see if we can figure out what's going on. Well, I put a little nitro in it and it started peeing everywhere. And then I realized that the compressor's missing one of its terminals. So yeah, we got a grounded compressor on this bad boy. All right, well, we're not fixing this today. Oh, look at that. Go figure, huh? That guy. That's not supposed to happen. Okay, well, there's nothing we can do about this. I don't know what caused the compressor to go bad. So we're gonna order a compressor, TXV, suction dryer, liquid dryer, and come back out and change it. This is really cute, huh? Look at this. Someone put a disconnect on top of the original electrical disconnect. God, I hate following behind other people. All right, well, yeah. So yeah, again, I have no idea what killed it, and we're gonna open the system up, so we're just gonna change the TXV at the same time. All right, it is July 5th. I am back. I was here on July 3rd when I condemned it, but we took the day off for 4th of July. So I've got a new compressor, brought my nitrogen, suction dryer, liquid dryer, TXV. We may or may not put the suction dryer in, it just depends. The gas is already recovered because it blew the terminal out. I did let the customer know it's going to be shut down for an extended period of time today because I got to take the panels and everything off to change the TXV. So let's get into it and see what we can hopefully get this done before it gets too hot. I think it's supposed to hit just about 100 today, so try to knock it out as quick as possible. I got the unit opened up, got the compressor all sanded up, TXV's accessible right there, got the dryer sanded up, so we know the system's void of refrigerant. I'm gonna start cutting out what I can. Well, actually, I gotta unsweat the compressor. Can't cut that out. I can try to cut out the dryer, it just depends. But the more you cut out, the more difficult it makes it to put the new dryer in. So it all just depends. All right, I got the dryer cut out. It had extended connections, so I was able to just cut them off, which is better if you can cut them out. Most of the time you can't, because if you cut it right here, there's not enough room to slide it back into the dryer. You got to cut back further. You know, it just depends on the severity of the situation. You make decisions based off of how much work you have to do, right? So what I did was I put a towel down there. We're going to give a couple purges with nitrogen. Now this entire system, we're going to be sweeping multiple parts of it to try to get any contaminants out of the system. Personally, I don't care for using additives or flushes or anything like that. I just like using dry nitrogen, pressurize, push it through, and see what we can get out. So let's go ahead and do our first purge right here. We're letting it build up. So all I do is hold my finger over it, let the pressure in the system build up, and then release it, so that way we create a big pressure differential in hopes that we catch something and sweep it out. I'm not even getting dirty oil coming out, so don't think we're gonna have a problem with that one. Usually you can see it with dirty oil right quick. So the next thing we need to sweep is we need to sweep from right here, and it should sweep back that way coming down. I took off my high side port, and look, it's dripping nasty black oil. Look at that. That's just from the oil stuck in that little trap right there. We'll have to make sure we purge that out too. While I've got this right here, I'm gonna go ahead and just blast this into this towel and hope that it doesn't, or I mean, to try to get some of the stuff out of that. Okay, so remember, this is just nitrogen, and we're sweeping out the contaminants out of the system. I gotta make sure we clean my gauges when I'm done too. All right, so now we're gonna hook up to this guy right here and try to push anything back that way. Now, why am I changing the TXV on this guy? The reason why I'm changing the TXV is because we don't know what caused this compressor to go bad. And on these TXVs, you have to pull the whole refrigerant charge out to do it. So we have the compressor out, we have a bad compressor. We're gonna go ahead and replace it because it's easy enough. It's right there, and it's a common failure part when the power heads fail on these things. Now, an even easier way to do it is I already changed that TXV, but it doesn't look new because I rebuilt it. This is the exact identical valve, so I just pulled everything out of it, put it in the new valve, right, and put it back together. Now, once I opened it up, it's a possibility this power head doesn't look too good. If anything failed in the valve, it would likely be the power head. It's very weak. There's a lot of corrosion on it. I can't necessarily push the bellows up on the power head, but still, it's something that we changed. So I just rebuilt it really quick, so that's back in there. And then now I need to get ready to put the dryer back in because I blew everything else out and I'm not seeing any other issues. I am still gonna do one thing, and we're gonna blow the evaporator out once I undo the suction line. But other than that, you know, we're moving along. So I'm gonna start getting the compressor undone and ready to go, the bolts out of the compressor, and getting ready to put the new dryer back in. I almost made a big mistake, big mistake. I was cleaning everything up and I noticed that this pin, I went to go assemble this valve and this pin wouldn't fit in the top. This actually is a different valve. So see how this pin fits in the top of this one? So I had this in there, but it's not right. So I am gonna have to sweat this in real quick. So I'm gonna clean it up, get the nitro purging again, and then we're gonna sweat in the body. I thought I was gonna be able to utilize that, but I can't. I very carefully bent the discharge line out of the way, and I just have it being held up by this towel. But you gotta be careful because there's a 90 right here. So I didn't bend it here. I grabbed this line and bent it here, because if you try too hard on that, you'll just kink that 90. You just gotta be careful about that stuff. So this guy's still completely intact. So unsweat the compressor, I'm pulling it out right now. Undid the bolts and everything, and sometimes you can get it out. Sometimes you gotta cut it, because I was thinking I was gonna have to cut it. That's why I sanded it, but I was able to move it nice and easy out of the way. Just to make my life a little easier, I'm putting ball valves on the dryer so we can change it later without having to recover the entire charge. And I'm gonna go ahead and braze this out here, flowing nitrogen, and then we'll insert it and only have minimal braze joints in there. It just makes it a little bit easier, but I can certainly do it the other way. It's just, you know, it's easier to do a weld out here if you can. So let's get on it real quick. So I'm being a little lazy. The last person that used my torches used a number 2 tip. So I'm just gonna go ahead and finish it with the number 2. It's a little big, but it'll be fine. Watch out because concrete splatters, so you don't want to heat up the concrete, run into problems. And again, we are flowing with nitrogen, so. Brazing on valves and different things is oftentimes a little bit different than normal brazing because you're always worried about protecting the valve and not overheating it, so sometimes your techniques have to be a little bit different. All right, we're all brazed in. I need to cool it off and then inspect everything real quick, make sure everything's good, which I'm pretty sure it is. Take all the heat blocking compound and then we'll get it put inside that guy and get the final braze joint in. All right, we're all brazed in, everything's good. I need to support the dryer with some plumbing strap and get it all cleaned up and cooled off, and then we'll get on to putting the compressor in. All right, we are set up here. Now, I wanna talk about a few things. Number one, I used a Sporlan catch-all a 163, so that's a 16 cubic inch 3/8 dryer with an HH core. The HH core is high wax removal. When you have compressor burnouts, depending on the type. Now this one isn't a severe burnout. I believe everything's contained to the compressor. I've still got a couple more things I need to do in the evaporator, purging that real quick. But so far, the dirtiness seems to be contained in the compressor as I'm blowing things out, because I'm not getting anything else. But it's always good bet when you have a burnout, when you have potential acid, that you use an HH core, because again, it has the ability to catch the wax that acids might, when it starts eating away at the windings, there's a wax coating on them. That wax can flow through the system and cause things to get gummed up. The HH core is specifically designed to catch that wax. Now, I went ahead and put ball valves on here, okay? With the ports on the inside, so that way I can, with the system shut off, I can ball valve these off, recover just the little bit of charge, and change just the dryer without having to recover 15 pounds of gas or however much this takes, okay? Next question, why did I use a 16 cubic inch dryer? This is a 5-ton system, okay? This is a 10-ton unit, but it's a 5-ton system. Actually, it's a 12.5 ton, but they're doing weird things with the evaporators, but it's a 5-ton compressor. But if you use the Sporlan catch-all box, they have a sizing chart. Now keep in mind, this sizing chart is for aftermarket repairs. Oftentimes you will see manufacturers using much smaller dryers on new systems because they don't expect a lot of contamination. But in the field, we're gonna use this sizing chart, and it tells you that a 16 cubic inch dryer is good through 5 tons of refrigerant. It also gives you the ounces of refrigerant by weight, so you can compensate, because if you go with a bigger dryer, you technically have to add a little bit more refrigerant to the system, so that helps you to do that, okay? So we're ready here. I need to put some Schraders in these guys right here, and then we can, like I said, continue on with the compressor. Oh, and then also, the other thing too, I guess I should point out, is I was protecting the ball valves, okay, and the dryer with a heat blocking compound, the Viper Wet Rag heat blocking compound. It's a putty. When it gets dried out, you can just put a little bit of a couple drops of water in there, mix it up, and then reuse it as much as you need to. Once it completely changes color, then it's time to replace it. But yeah, this is from Refrigeration Technologies, and you can see that it did a good job of protecting the top of my dryer, the ball valves, because there's Teflon rings in here and different things that we don't want to damage, okay? So it's very important we protect our stuff as best as possible. I was able to take the old strap and just get a long screw. It went through, but it didn't go into the coil. It's just right in front of the coil, not even close, not going to damage it, and it's cinched down really tight. So with the added weight of the bigger dryer and the ball valves, you got to be careful, and this becomes a weak point right here because it's got all the weight. So I pulled it up ever so slightly, tightened it down, and we're good on that. Now we can test pressure drop across the dryer and get a true pressure drop from here to here if we need be. So I'm going to probably go ahead and put this cover on, and then like I said, we're going to get into that compressor now. I was just blowing out the evaporator, and nothing's coming out the suction line, but I could hear oil bubbling in this guy. So I ended up cutting that, where I was trying not to, but I ended up doing it because I suspect that if I tilt this over, we're gonna get nastiness coming out of it. Look at that. So that's the remnants from the compressor that it had like blown out or something. So I'm gonna get in here and blow that out with some nitrogen too, trying to clear that line. I can look up into that discharge line right there. It's not very dirty. There's a little bit of stuff in there, but nothing bad, right? I can look into the suction line. It's not that bad. It seems like most of the stuff is contained to the compressor. I blew out everything with nitrogen. I got no nastiness from over there or from over here when I blew it out, except for on this. So what I'm actually doing, instead of flushing, I'm using polyester oil, filling it up with polyester oil, letting it wash the walls of the pipe, and then pouring it out, and you can see the stuff that's coming out is pure nastiness. I'm gonna do one more, then we're gonna give it some sweeps with nitrogen, and then hopefully we'll be about done. All right, I got the nitrogen flowing. I got the compressor installed. We didn't put the bolts in yet. We'll deal with that in a little while. I'm purging. I got a coupling right here. Everything's all sanded up and ready to go. So we're gonna braze these guys, this guy, and then we'll be ready to pull a proper evacuation on this guy. All right, compressor's all brazed in. So I'm gonna clean it up, and then we're gonna get the vacuum pump stuff up here and start pulling a vacuum on this guy. Actually, we should probably do a pressure test first. So we'll do a pressure test, but we gotta cool everything off. Been running the pressure test for about 6 minutes. We've lost nothing. For a moment we actually gained pressure, then it like went to 124.2 and then come back down. That's all the nitrogen I have, but I'm confident we don't have any leaks. So I'm gonna go ahead and vent that, just the nitro, let it come out of the system, and then we're going to start cleaning up and get ready for an evacuation real quick. All right, my unit is on and running. I went ahead and pulled the filters out because they're plugged. I've got the vacuum pump running. It's not ideal, but I have it just on the compressor. I pull it from the low and the high side. Got 2 micron gauges on there, but I have the system running. The reason why it's not ideal is because that sucks in outside air, but it is what it is, because I wanted to get their second stage at least running, so that way they could have something while I'm running to go get parts. So I'm gonna leave the vacuum pump running. I'm gonna get some filters. I'm gonna see if I can get a crankcase heater, because the crankcase heater on this compressor was bad. And when I picked up the compressor, I tried, but none of the supply houses in my area had them. But I'm a little ways away. I'm gonna go to a different one. We'll see if they have it. If not, we'll have to order a new crankcase heater. It's a little odd because it's a 40-watt one, and the supply houses typically don't stock that one. But yeah, so we're pulling, and I'm gonna go do lunch. All right, scratch that. I ended up having one of my guys get freed up for a minute, and he's passing by me, so he's gonna bring me all the filters. The evacuation is kicking butt, a lot faster than I thought it was going to. We're about 453 microns on that one, 443 on that one. So we're gonna let it run for a few more minutes, but what I'm gonna do is I'm gonna change this contactor, because I think this might be part of the reason, if not the only reason, why this compressor went bad. It's really pitted out, and when I had to put a new Molex plug on it, this little guy right here. Okay, when I put that on, these screws were not even tight. They were like loose right there. And then I looked at the contactor, and it's really bad. So I've got a new contactor right here. We're gonna go ahead and swap it out. I turned off power to the unit, and then this guy's going so fast, I'm gonna be able to start it up here in a few minutes, but I wanna get this contactor changed out first. Contactor is replaced. We're good to go. Cover's right side up. The old one is just really pitted. It's hard for you guys to see, but let's check on my evacuation. We'll go ahead and hit our decay test. We're at like 300 microns on that one, 400 microns on that one. So we'll let it run and decay for a little bit. I'm gonna go get some refrigerant, and we'll get this guy charged up hopefully in a minute. Right, I zeroed out my scale. We are looking for 16 pounds, 8 ounces. Micron gauge is at about 951, 760, so we're good on that. We're gonna go ahead and start putting gas into the high side. Okay. Close both of those down. We're zeroed out on the scale. And put that on, put that on. And then we're gonna go ahead and dump it in on the high side. Right there. All right, so we're putting 410A in this system, putting as much as we can in the high side, then we'll meter the rest in through the vapor side. And again, we're looking for 16 pounds, 8 ounces. I'm gonna go ahead and take these guys off now that they're at high pressure. So these guys can handle positive pressure. So as soon as you get into positive, just take them off. You don't wanna put too much pressure on them, but they can handle it. And that's it, I'm just charging. Right, it won't really take any more than 6 pounds of gas right now. So we're ready to turn this guy on. Everything's back on, the Molex plug is on. We should be good. Everything's closed. I'll add refrigerant after it turns on. If it short cycles, I'll push in the contactor. So we should be good. Just like that. Let's just hope nothing blows up, huh? So we gotta wait for it to call. So we don't have a call as of yet. We'll give it a minute. The test mode on these Prodigy 1 controllers is dumb. Some of them, if I remember right, it only turns on the compressor. It won't give it a full call, like first stage call. I don't know, it's silly. So I'm not gonna bother. I'm just waiting for the time delay to finish on the thermostat, and once it calls, then I'll start charging it in here. And we are running. Compressor's not making a weird noise, so it's not running backwards. We're gonna go ahead and meter refrigerant in through the low side because it still needs 10 pounds of gas, so we're gonna try to do it before it goes off on low pressure. So I'm just slowly metering refrigerant in. We're up and running, off to the races. Right. We are fully charged. It took 16 pounds, 8 ounces. I overshot it just a little bit because I'm gonna be taking my gauges on and off. I usually overshot it by about 4 ounces because I'll probably lose about that much when I take my hoses off. I am gonna probe up on this guy, but it's not looking bad right now. So I'm gonna let it run for a little bit, take a lunch, and then we'll come back and probe up and we'll do a pressure drop across the dryer. I'm just gonna clean up a few things. I've been kind of cleaning up as I've been going today, so I don't have a lot left up here. Every time I went down, I've been cleaning up, and my tech did show up. He put the filters on the back dock for me, so I gotta go get those too. All right, I am back from lunch. We are all probed up. I got some new filters to put in all the units. Haven't done it yet, but I will. We're just looking at this guy. So took off my normal gauges, put on my probes. This is looking really good. Things are ranging, expansion valves open and closing. Nothing too crazy there. Subcooling's high, but it's using discharge pressure, so that's pretty typical in these. Outside air temperature is about 95 degrees. Discharge line temp, 151. Let's go ahead and go to circuit 2. Superheat's about 6 degrees. Let's give it a minute, watching it operate. Same thing with subcooling. It's a little bit high, but I'm not too worried about it. Outdoor air, same temp. Discharge line temp, 161. Don't see any issues there. Temperature split's about 24 degrees. What are we calling for? We're calling for about 23 degrees right now based off of the indoor conditions, so that's not too bad. Let's see, our delivered capacity is about 126,000 BTUs. We're calling for about 134,000. Again, I don't see anything too crazy with that. We're looking pretty good. So here's what we need to do. I need to go back and we need to get a pressure drop across the liquid line filter dryer in here. We're gonna get a pressure drop so that way we know what it'll be next time we come back. We know, when it's high or low or whatever. So I'm gonna do that. We are gonna schedule to come back and chemically clean all these condensers. I'm not gonna do that today because I've been on the roof long enough. I did tighten up the belt. The belt was loose. I'm gonna put filters in all the ACs really quick. And they got like a photo cell falling off. I'll have to look and see if there's something I could do about that. But other than that, the unit is operational. Everything is good. We probably need to come back if the customer's cool with it and do a pressure drop test on the liquid line filter dryer, and then probably, if we can, do an acid test to see if I was able to clear out most of the stuff. The dryer should be working its butt off. Now, if this was a severe contamination, I would suggest putting in a suction line filter dryer, but I opted against that because it's kind of difficult to get those in and out. So if I can get away with just a liquid line filter dryer, we're better off. Oftentimes this customer won't have me come back, so if I have a suction and a liquid, I don't know. It's just kind of a pain in the butt. You have to make judgment calls when you do that stuff. So, well, let's do the pressure drop across the dryer real quick. The numbers are kind of fluctuating around right now, but so far, temperature difference wise, it's about 2 degrees temperature difference between suction line temp is one side of the dryer and liquid line temp is the other side of the dryer. And then pressure wise, it's 3 to 4 PSI. It's kind of moving around as we sit here and wait longer and longer. But so I'll mark it down as 4 PSI and 2 degrees on the temperature differential. So we're working okay. Like I said, we'll give it some time. If the customer's cool with it, we'll come back and do another pressure test across that dryer, and then maybe do an acid test if we can get some oil out of the existing compressor. What caused the compressor to go bad? I really think it was that contactor. But that was a really nasty burn, so I'm sorry, it wasn't a really nasty burn, but the inside of the oil of the compressor is pretty bad. If it was really nasty, I would expect there'd be oil all throughout the condenser evaporator, and I didn't see any signs of that. I only saw it in the discharge line, about a foot above the compressor, and everything further down, I didn't get any remnants of oil, nasty oil. So if it had traveled through the system, I would have definitely done suction line filter dryer, maybe ball valve that off, and then come back out and isolate it and stuff. You can even put in flare valves or flare dryers. I didn't really see the need for that, so we'll just keep an eye on it. And but like I said, I'm not going to cut that compressor open because it's pretty nasty, so I don't really need to be making a mess with that. I kind of have an idea. I think that because we blew a terminal out, I think we had some voltage issues. That's my guess on it, but I'm not going to know for sure because, again, I'm not going to cut that one open. No time for that right now. So that's it for this one. We're going to give the customer the keys. They're super stoked because it's cooling off in that kitchen significantly. I'm going to put all these filters in, and then I'm going to get the heck out of here. You know, when these customers aren't doing, you know, normal routine maintenance, it makes it difficult when we come out to these service calls because, you know, these problems, you know, there's a possibility that we would have caught this before it became a real issue, right? And if we're not, like, we used to be there monthly, cleaning all their equipment, making sure everything's good. On this unit, it's not, the condenser was a little bit dirty. The evaporator was surprisingly pretty clean, but the filters were dirty. So the filters could have had something to do with the compressor failure. The compressor contactor could have had something to do with the compressor failure. The crankcase heater being bad could have had something to do with it, but I don't think it was the crankcase heater because I didn't catch it on camera, but when I took that compressor down to the back dock, I did pour the oil out, and there was plenty of oil. So there's not oil trapped in the system anywhere. It just blew the terminal, and surprisingly, it didn't blow out all the oil inside the unit either. Like, it just vented. That's why I really think it had something to do with the electrical failure. I think the contactor being pitted, not sending proper voltage, and then maybe, you know, potentially a loose connection on the inside of the compressor on the other side of the Molex plug. It's hard to say, right? In a perfect world, I'd love to autopsy that compressor, but I just don't have the time right now. We're running and gunning. You know, it seemed like summer was taking forever to get here, and then it just hit us like a brick wall. We got all kinds of stuff going on. So that's not one that, plus the fact that that oil was so dirty, I really don't want to cut that thing open. It's going to be a nasty mess, and I don't really need that right now. So this one's just a mystery, but we are definitely going to monitor it. I'm still going back with a crankcase heater. Okay, I ordered one of those. And I will do a pressure drop test and temperature drop across the dryer again to see if I see anything. And then we'll just monitor the rest of the system. But another thing I noticed too, as I was changing the filters on the rest of the package units, there's like 2 of them that the evaporators are completely plugged up. So we'll have to get to that too. And cleaning the evaporators on these units, if you can keep your equipment with clean evaporators, it's better that way, right? Obviously for airflow and proper operation, but these are downshot units, meaning that if I try to wash that evaporator, it's a slab coil at an angle. When I try to wash that, that water goes directly down into the return air and drips right down on the customer. So it's just a pain in the butt to clean these evaporators when they don't maintain them like they should be. So, you know, we'll have to bring that up to them. But right now we got, like, you know, a bunch of service calls and a bunch of big issues going on that, like, I can't really bring up evaporator cleanings. Like, that's a hard one. And cleaning those evaporators, if, like, even just one evaporator is pretty much a one-day process. You got to put down plastic trash bags, sheet pans, like all kinds of stuff to capture the water because they're so dirty. It is a pain in the butt. But anyways, I did my best to make sure that this system was operational. It is up and running. You know, I kind of like was going back and forth on whether or not I wanted to install a suction line filter dryer, but I decided not to on this one because I didn't think the contamination was that bad. Who's to say though? We'll see when we go back to do a pressure drop and temperature drop test across the dryer to see if we notice that the dryer's starting to plug up or anything. I really don't think it's going to. I think, like I said in the video, the majority of the contamination in that compressor was contained in the discharge line. And it wasn't even, like, I could stick my finger into the suction line and it wasn't even that dirty in the suction line either. So it just, like, blew whatever it was just into the compressor discharge line right there, and it didn't really go that high. So, you know, I kind of got lucky on that one. I mentioned in this video, I didn't really go into depth. I'm actually giving them a quote too. I mean, with this customer, like, when I give them quotes, they pretty much approve it, but I have to rebuild their makeup air unit. They have an evaporative cooler. It has 2 water pumps. I showed it in the video really quickly. It needs all new cell deck pads, new pre-filters, temperature controller, water pumps, water float, a full breakdown and cleaning. I did turn that evaporative cooler back on the first day that I was here, and then when I got there this morning, it was leaking water everywhere, but it's not leaking into the building, and the customers, you know, it's giving them a little bit more supplemental cooling in the cook's line because it kind of tempers the air. So, you know, if you guys haven't already, please consider checking out my website, hvacrvideos.com. My wife, you know, she really tries to keep up on the merch and everything. So we have hats available. That's like our #1 seller. We have a couple different brands or types of hats. This is my go-to. This is the, what is this one called? Clean and, no, it's dry. I don't know. It's an active wear hat. I've said it many times before. This hat, you can't see it on camera right now, but I can see light through the hat. It's a black underbill. Put a lot of design into this. It's very breathable. You don't sweat very much in this hat. We also have a flat bill hat. We also have a relaxed dad fit hat. We have beanies, sweatshirts, t-shirts, women's t-shirts on the website. I'm wearing this one. This is the flag t-shirt. This is available in the women's version too, and it still has the flag on the sleeve. So just check it out, hvacrvideos.com. A couple other ways if you're interested in supporting the channel. The easiest way is literally just watch the videos from beginning to end. That's the easiest way. PayPal, Patreon, YouTube channel memberships. Those are all different ways that you can donate to the channel. There's links in the show notes. Another really cool way is through TrueTechTools.com. If you guys go to TrueTechTools.com and you like something that they have, I have an affiliate code, an offer code. If you use my offer code, big picture, one word, you get an 8% discount on majority of the items on their website. Not everything. There's a few things it doesn't apply to. But when you use that, I get a small commission. So it's a great way to help support the channel too. So check it out, TrueTechTools.com. I really, really appreciate you guys. Thank you so very much for all the support, the kind words, the encouragement, the feedback, the criticism, the comments. I grow from it all. So thank you very much. And we will catch you on the next one.